Welcome to our wrap-up session on Vulcan 10. Today we have a panel packed full of Vulcan experience, eager to answer the questions you have submitted. Although time is tight, additional questions can be asked during the session by entering them in the question box in the GoToWebinar panel. Before we start on your questions, each of the panel members will show their favourite Vulcan options in version 10. Now, Stephen Hoffler, you're first. What have you prepared for the viewers?
So my favourite option in version 10 would be our new open pit solids menu. This is a new reserving tool and combines a lot of our Boolean tools into a nice, neat, automated workflow that creates your solids, reserve your solids, ready for scheduling. We have previously done a detailed webinar on these menu options, so I am only going to, briefly touch on some of the options, and we'll send a link out to the existing webinar so users can watch that at their leisure. But essentially, if you go into the setup panel, we've got two different modes, which allows us to essentially cut by horizon or cut by bench first. So with the horizon mode, it'll cut by horizon, by strip, by block, and then you can bench. Or if you go in the bench mode, it'll cut by bench first, then strip, block, and then horizons last. Everything gets attributed onto our solids, so we've got a lot of geometric attributes that can be added in, thicknesses and areas. There's a few other options. I guess the main ones coming down to is the projections. So we can just apply 2D strings effectively, and we can auto project these on the fly through this panel. Or alternatively, when we get down to these other options, you can actually provide your own already projected strips or even pre-built high-wall templates. You can read in a variety of sort of Vulcan standard spec files, or you can actually just create your own horizon list on the fly, which is essentially going to define what horizons it's going to cut your solids by. We get a quick look at the strips, so you can define either lines to project, lines already projected, or high walls. We can then define our blocks by either lines or triangulations, and we've also got a new naming panel down the bottom, so you can actually name the solids using any of the attributes or any fixed naming as you see fit. We've also got the benching option, so we can actually apply benching to our solids. We can only bench certain material types or certain seams. We can do fixed benching or even variable height. So we've had a lot of users who've asked for sort of like 4 metre, 4 metre, 4 metre, 3 metre type sequencing for their heights. So you're able to do this through the variable bench heights. And we can also reserve on the fly. So whether you reserve from grids or whether you're reserving from a block model or a heart model, that can all be done. Automates the whole process and basically runs through and produces a series of solids at the end of it. As it goes, it creates all your different solids in different folders, so they're easy to locate and find. And some other panels that we have in that option is the clip solids and update solids. So once you've actually run the split pit option to get your scheduling solids, if you've got a new quality model or you've got a new topo surface, there's no need to run everything again. So with the topo surface, you can just run the clip solids option, and it's like a keep above or keep below scenario. So you can actually grab all your solids, grab the new surface, and re-chop them up. And you've also got the update solids option. So once you've cut it, or once you've got a new model and you need to re-reserve and update some of the geometry, we can run the update solids. And again, it's a new reserving tool that you can reserve to either grids or heart models and attach all the reserves as attributes. As they are attributes, we do have options to actually export the attributes to a CSV or text file. And there's a lot of options in there to actually format that how you like. And then we've also got a new triangulation visibility panel where you can actually start hiding or shadowing or making invisible different solids based on different parameters you set. So at the moment, I've just got a pit that's been cut up, and I've actually coloured it by material type. So we've got our overburden, and then we've got mid burdens, we've got coal in the pink, So using some of our existing tools and some of the new tools in 10, we can start to actually interrogate the data to try and make more sense of it. So the first one we can play with is the visibility option. So the first thing I'm going to do is just load all the attribute values in so it knows what I can choose and what I can't choose. I'm going to say I only want visible. I can say, for example, where material is equal to coal. I can hit apply, and that automatically hides all my overburden, mid-burden solids. So now I've just got coal seams left. So that's good, but I've got 3 or 4 different seams on here, so I actually just want to narrow it down to one particular seam. So now I can start combining some of these filters, and I might say the seam I'm interested in is maybe the RE upper. Hit apply or OK. So now all I'm left with is those particular solids for that particular horizon. They are all attributed, so I've got all my reserve information. And as we've got some qualities reserved on these, I can use some of our current tools, such as our colour by attribute option, where I can use just the solids on the screen, and I can say numeric value, I want to use the ash, and I've already defined a colour legend for my ash. So we can run through that to colour it by our different colours in our legend, and then I can display that legend just to make it a little bit easier to see what's what. So these are my favourite tools that have come into version 10, combined with some existing tools in our colour by. Makes it a lot easier to actually prepare your designs for scheduling and actually interrogate some of your data if you've reserved it to actually get more of a feel for how your pit's looking.
Thanks, Steve. That's a good wrap-up of that. Over now to Peter Owens. Peter, you've got a demonstration there of Eureka and Envisage, so over to you.
Thanks, Steve. So my favourite thing is, I guess I'm going to cheat a little bit and say it's the actual Workbench interface we released, which Vulcan 10 resides within. As the first incarnation was released in March this year, it already gives us a lot of useful new features, things like the command lists, which allows you to build up workflows within Vulcan, ISIS, any component of Envisage, which can guide users through, tasks, menus, and prompts and things like that. And as we'll see soon, we've expanded on that greatly for 10.1. There are the filtering options on the various drop-down lists of file types, which make life a lot easier to find exactly what file you're after, and lots of nice ways to view things. The multi-language capability, maybe not so much here in Australia, but certainly our international clients are really getting the benefits of being able to see the software in their own language and work with it natively right through the menus, the layer names, everything you can basically create within the software. And of course the whole multiple windowing environment where you've got set up your actual view and how you set up Vulcan in the interface to suit how you want to run it. And finally, I guess the addition of utilities such as the text editor, the CSV editor, which we are forever expanding upon to put handy functionality within the grasp. So the interface itself is giving people a lot of extra value in addition to the functionality enhancements. Now moving quickly, a bit of a sneak peek for 10.1, we've actually got for the first time a new product fully integrated into Workbench. So you can see I've got Envisage, ISIS, and now Eureka. And what this looks like, well, Envisage, of course, here's some triangulations I made using the actual Eureka implicit modeling tool. Here's the Eureka interface itself. So now I'm looking at data purely in Eureka. My menus have all changed to be Eureka menus. My Explorer here is a Eureka Explorer. I can create implicit models in here, quickly access them in Envisage to use with the rest of my data if I want to do that. If I want to see, for example, the database behind this, we've got ISIS sitting here. And then other things like this is a bit of a sneak preview of the workflow tool, which is going to turn up in 10.1. This will allow you to actually create multi-products, multi-task workflows using a dynamic interactive interface and putting in loops and scripts and whatever else you want to include in it in a very powerful new tool, which will make life a lot easier for those who want to standardize operations across the board. So I guess in summary, my favorite thing about Vulcan is a bit like saying my favorite Christmas present is the one with the best wrapping around it.
Thanks, Peter. That's a good wrap-up and good to see some new functionality that I haven't seen yet myself. So nice to share that with us when it's released next year. Now I'll move over to Eduardo. Eduardo, you were involved in a couple of new projects which are in development for release early next year. And can you share us some information with our viewers today?
Thanks, Steve. Hello to everyone. Yeah, look, today I want to share 3 things with you guys. One of the things is my favorite tool in Vulcan 10, and also what we are improving in one particular option that we delivered in 10.0, which was the automatic pit designer. And finally, I want to share with you one of the tools that we are developing as we speak now, and hopefully will be very useful for the blast master generation. So let's move on to my favorite tool now. This one is the ability to create a solid between surfaces. This data set here, it seems like a quite simple, but it's not. Essentially has all the complexity of the real data. You've got a different resolution of triangle, a small resolution here, big triangle in here. If we generate a section view to take a look to this data, we can certainly see that the area doesn't match at all. You got some cut, you got some fill, you got some area with their complete overlapping. So it's a very real data set. And the option that I want to share with you how you can actually create a solid between these 2 surfaces is under Model Triangle Solid Create. So essentially, it's a new option underneath the previous one, which is Create Solid from Surfaces. It's very simple, very straightforward. You need to pick up the initial surface, which in this case is that one, and the final surface. You can also try to remove some small fragment if you want. But let's give it a go and see what happens. So let's remove the original information here. This is the result. Let's change the color a little bit to make the life more easier. So now we've got 2 different triangulation. We got the cut and we got the fill. One of the interesting things with the property editor, you can actually click one of these triangulation and get the value, and the system is going to generate the check for you and also calculate the volume and the area in one shot. So this is one of my favorite tools in Vulcan 10. We are having a lot of success using it with different customers. So I encourage to try, and if you got a challenging data, please contact us and we can take a look. So the second thing that I want to share with you today is one of the options that we launched in Vulcan 10.0, which is Automatic Pit Designer. This option allows to generate a pit design reading from the block model. So one of the there we go. All right, so this is the initial panel for the option. Essentially, allow to the user to create an automatic pit design reading from the block model, or even using a string. We got a full webinar on our web page that you can actually take a look and in more detail. I just want to put the focus in this webinar about what we are actually improving for Vulcan 10.1. One of the interesting things that we are adding in this new version is the ability to create the solid on the fly, and also the topography after the pit has been mined. So essentially, this is the traditional result that you can get in Automatic Pit Designer in Vulcan 10. Now what we are doing essentially is improving this one and give you a little bit more flexibility in order to get the final solid and the topo, how the topo looks like after the pit has been mined. So this is one of the things that we are actually putting in 10.1. Another interesting thing is part of the process when you really want to get a solid is calculate the reserve. So we are incorporating in Automatic Pit Designer live reserving and reporting, so that will be available for our user as well. Another thing that we are putting there is the exclusion zone. Sometimes the user wants to exclude some area, even if it's part of the result of the optimization for some operational reason. So you can actually now have the ability to exclude this area. And finally, we are adding an external executable. So the user that like to run macros on or generate some automatic process, or even use our workflow coming in 10.1, they will actually can use this external program as well. So that's basically the new thing that we are incorporating in Vulcan 10.1 in relation with the automatic pit designer. So the last thing that I want to share with you guys is one of the new options that we are working for Vulcan for the next version is we call it mining block generation. Essentially, what we're trying to achieve here is trying to generate blast master in an automatic way for a metalliferous point of view. So this option is very straightforward as well. We got a specification file here. The idea is the user can start with the topography and then with the pit design. So one of the products that you can actually get from this option is the solid, the benches, and then the blocks. Everything is very straightforward, so you can say different kind of information here. And then we can include some operational constraints like a trim polygon, run polygon, and production polygon. Everything can be reserved on the fly, and everything will be output in triangulation. So at the end, we are going to have a specific folder and then different information that you can get from this process. So the first one is the solid between the surfaces. We also are incorporating some information regarding with the topography after the pit has been mined. But the more important thing is when we actually took one of these push, but can be one or all of them in one shot, it's just a matter of time. But the system is going to break down the information by bench automatically. Again, probably all this option already exists. The thing that we are actually doing is putting in a single spot and trying to speed up the process. So now we've got the benches here. And finally, basically what we are looking is essentially cut all this triangulation in one shot. So everything was cut into blocks, in this case using a regular block. Let's take a look in one particular plan view. There we go. Yes. Let's see what's happening here. So we got a different solid that you can actually interrogate. Those solid is going to have some attribute as well that you can use it for scheduling purposes. You can visualize them using the tool that actually Stephen Hoffley showed before me. This is one of the things that we are actually doing, regular grids. Our final goal is actually trying to come up with more operational CAD. So this is what we actually working at the moment, is the user is going to have the ability to generate in an automatic way the ramp, the trims area. The trim is going to have some parameter like the distance, and obviously what will be the volume that you want to achieve for each trim blast. And then finally, you're going to have the ability to generate the production blast. That, again, the main purpose of all these things is trying to speed up the process for information required for a scheduling point of view, and then can be consumed by different products. Can be short-term planner, can be Vulcan Gun scheduler, or can be Maptek Evolution Epoch. So that's what I want to share with you. Thank you, and pass to Steve.
Thanks, Eduardo, and I'll just wrap up before we get on to your customer questions. Just my favourite part of Vulcan is the Vulcan Data Analyser. So I guess just from the concept of being able to get a database and very quickly interrogate it and get information about that on the screen. It's something that is a new interface. It's very dynamic. It's very interactive. Data comes alive very quickly. There's a lot of easy-to-use controls to modify the data. If you don't like what you see, you can just dynamically change things on the fly. Various different slider bars to control orientations, various different things to do with all the different parameters that you may be considering with your variograms. So again, a second one, if you've got a particular direction you like, you can then come through and say, let's try 30 there, let's try 150 there, calculate that, and comes through. And again, we've got 3 variograms in different orientations on top of each other. We can break those out into the different components, and major, semi-major, and the minor. If you want to have a look at the downhole variogram from the same data, you can do that again to fill in this box. So a very easy to use interface, very dynamic. We can change things on the fly. For any of the parameters, you can change your annotations. You can model your variograms. You can export to image files for your reports. It's very easy to export to a VRG, a variogram file, for incorporating into your grade estimation in Vulcan. So that's my favourite for Vulcan 10. Now, of course, the most important thing about this forum is answering your questions. So we have had quite a few questions that came through to us, and we'll be answering them around the different offices. And I'll pass you across to Stephen Hoffler, who's going to share some information about the question on the screen there. I'll read that out while the screen changes over. When will small errors in Vulcan 10 be fixed? Will it be Vulcan 11 or releasing patches like other software? Over to you, Steve.
So currently, Vulcan releases a new service pack every 2 months. So we released version 10 back in March, and currently now we're up to version, or service pack 3, or 10.03. 10.04 is due to be out around about Christmas time, and then we're aiming for 10.1, which is the new release, to be out around March next year. So releases once a year. Releases will include everything: bug fixes, minor enhancements, and sort of major projects or major changes, where our service packs we're trying to limit to not only bug fixes, but also small enhancements and small changes. And I guess to highlight some of the things, like we did have a few questions around resequencing that come through. So just to show, in 10.03, it is now performing as expected. So if we go to our point edit resequence, in previous versions, if you resequence just a line that had 2 points, it would actually disconnect and just leave you with 2 points. But now we can select, I want the new start point at the top, and you can see it's just resequencing as it should. So that one's been tidied up. And a few of the other issues we get coming through for support relate to the Vulcan Explorer itself, in terms of not refreshing properly or things out of order. So I'd just like to highlight that we do have this suspend file level button here. So we do have, if that is clicked on, when you save, when you delete stuff, they may not automatically disappear and reappear in your Explorer window. You may have to actually manually refresh it. So if you are having some of those issues, just ensure that's not ticked on. So if it's ticked off, it should be sort of auto-refreshing. And in terms of the ordering, if you come into your Explorer options, there are a whole sort of range of different things you can turn on and off, and different ways you can order the Explorer files. So sometimes if some people are changing it, they might have a different ordering than if you open up that data, you see it in a different order. Just go in and check on what's actually been selected in some of these parameters. And I guess the main final one we have coming through support, which may not necessarily be a Vulcan error, but it does affect how Vulcan performs, is the graphics cards. So we encourage, as Vulcans now move more onto the graphics card and the GPUs for all its processing, we do rely on the graphic card drivers a lot more. So it does highlight issues with older drivers having some bugs and whatnot in them. So we do encourage everyone to update to a sort of latest and greatest graphics card. Probably doesn't need to be done all that often, probably like once or twice a year is fine. But we do see a lot of people that phone in and say, I've got a new laptop, it's all good, but when you look at the driver, it's actually 2 or 3 years old. And not only the driver, it is also the settings inside the driver. So I've got an NVIDIA Quadro card. So if you open up your NVIDIA control panel, come to your Manage 3D settings, by default, it'll be on base profile. But now we've got all our products coming into the Workbench, and we want to have a common setting across all the products. We've found 3D app game development is a really good setting to use. And I guess another one that's also proving pretty successful is the visual simulation setting. So it's not only updating the driver, it's also coming in and setting up your global settings to ensure you get the optimum use out of Vulcan.
Thanks, Steve. And the next question has come through, and I'll throw to Peter Owens on this one. Can you show us some tips and tricks when using implicit modelling, including some reliability of the output?
Yeah, certainly. Thanks, Steve. The first thing with any sort of modelling is understanding of your data. So there's a few tips and tricks to doing that. In this particular example data set here, I've used the scale option on the drill holes themselves to highlight the intervals I'm interested in actually doing the implicit model of. Very quickly, for those of you who don't know where that lives, you set up a legend under the legend editor. Oops. And that allows you to access the pattern legends. Then when you load the holes, it will allow you to set a disk width, and that's then highlighting the intervals. The second thing you need to know is the sort of distances you're working with. So if I use my analyze distance option, want to know what the distance is between this hole, say, and this hole, I can look down here and I can quickly tell whether I'm looking at, so that's 80 meters. So it's important to know whether that's, this sort of distance here is 80 meters, 2 meters, or 2,000 meters, because that's going to affect what settings you put in the final modeling run. Once you have an idea of your data and a good understanding of it, and I assume it's valid data to start with, the implicit modeling option itself, there's a few things you can do to make life easier for yourself. Of course, it runs off a spec. You've got two options in 10, Kriging and radial basis function. Irrespective of which one you want to ultimately use, I would start with Kriging in that it's quicker to run. So you want to get it so you can sort of do test runs in several minutes. Okay. Obviously, you choose how you're going to model it. If you've got your own compositing done, do that first, and you can select straight from the compositing database. Otherwise, go from drilling. Down here, there's slice options. There's a few tools that allow you, once you've done an initial run, it'll automatically give you a dynamic slice of the block model it creates and solids it creates. And the beauty of that is you can start tweaking options in the panel, and it will dynamically update that particular thin slice of the view of your data without having to rerun the entire model. So it's a great way to sort of fine-tune and make sure things are behaving themselves before, again, you commit yourself to the complete run. In terms of the parameters, leave everything, the KISS principle, keep everything simple, because you want to just keep your smoothing down. And certainly in terms of the block model, again, choose a block size. So I've got 20 by 20 blocks here and 2 meters in Z. So you're going to end up with, say, a couple of 100,000 blocks in the modeling run. And one thing you can do is once it starts running, it will throw up the T-shell. It actually shows you how many blocks it's working with. And if it comes up saying 25 million blocks, I would just cancel out of that and come back and reset this. So again, get it initially to run in a couple of minutes. In terms of locating where the block model is in space, use the digitizing option to digitize it in plan, and then obviously understand your data's range in elevation, which can be easily done through Vulcan using something like Analyze Detail Layer Range or something like that. The domains and search ellipses and such, one thing to watch out for here is the default setting for the minimum number of points it's going to look for is 4. So if you're running it and finding it's not creating anything or missing bits of your data, it could be the fact that your data is so sparse it can only find 2 or 3 samples. So first off, set this to 1. So it's going to find the nearest sample at least and do something with it. Similarly, the actual distances you're working with, don't just take the defaults as being correct. These defaults have to correspond to your data. So again, knowing how far apart samples and things are. If you're using a categorical type rock type thing, my rock types are actually numerical here, but it'll automatically create that for you from the data, so you can't get that wrong. But obviously, if you're doing something like an assay, make sure you've got the correct naming in there. And then wherever you can, use options like the interactive. Once you start getting into your structure, use something like the interactive ellipse, which allows you to dynamically start positioning where your search ellipse is going to go and what sort of orientation it's going to have. So again, rather than trying to type numbers in panels that may or may not be correct and find out you're doing the wrong thing, use the sort of nice visual tools that we give you to set things up correctly. And so do your first pass, get it running in a few minutes, use the preview options, and then come in and think about adding additional polygonal control, or advanced options for faulting and such, or sample restrictions. And of course, come back and come down to your final block model resolution. And again, you want to trade off between speed of running and size of and accuracy of model, but getting less than about a fifth of the data point separation is just wasting time. In terms of comparing the final model, then obviously it's going to give you a block model with the rock types estimated or the grades estimated. It's also going to give you the solid triangulations, throw them back into Envisage and compare them against the input data you gave it. And that way you can sort of guarantee that the answers are making sense to you rather than just having them sitting in space in isolation. Okay, thanks.
And another one for you, Stephen Hoffler. Is there a better way to create Boolean triangulations for very complex underground cavity scans, cavity monitoring scans, or against stope designs? So we're really looking at managing overbreak and underbreak, and have we got a better way to do that? Because currently the customer's taking about 30 minutes per stope.
So dealing with solids and, I guess, underground stopes. So I've got two solids on the screen. The red one is our design stope, and then the grey one is our sort of as surveyed stope. I'd just like to highlight, I guess, two options that we can use. So under our model triangle solid option, we've got an option called differential volumes. So essentially, as a first pass, if you're just after some numbers, overbreak and underbreak volumes, to get out into a report, we can run this. We can select our two surfaces. We can put it in, save it out to a report file, and essentially even in our Envisage console, it's going to report out which two triangulations we're using, the volumes of the two, the common volume, and then you've got a cut and a fill, and it'll give you a description at the bottom where one's overbreak and one's underbreak essentially. So that's a nice, easy, quick way just to get the actual numbers. But if you're actually after the individual solids themselves, so an overbreak solid and an underbreak solid, under our triangle utility menu, we have merge. And inside the merge option, we have about 6 different submenus. And the one of interest for this exercise would be the solid difference. So with the solid difference turned on, I hit OK. If I select my actual scan first, and then the design scan second, the difference that it's going to actually calculate for me is our overbreak. And I'll just hide these or remove these original scans, triangulations. So now what we're left with is a solid that represents the overbreak, or the areas that are outside. Might look a bit holy and not that pretty, but we can check it by running a volume, leaving our tests on, and we get our volume come through. And so that's for our overbreak. And essentially it's the same process for our underbreak, except this time we select our design surface first and then our actual surface. This should give us a underbreak solid. So again, just remove those original two. Now we're left with all the bits and pieces that were outside, and they are all basically appended together as one solid. And we can check that by running a volume, leaving the tests on, and we get our underbreak volume. And so we can see the Envisage console, we've got the 604 and the 2413 from our differential volume option, and we've basically got the same numbers from our actual solids. So we can be pretty happy that a quick way to create our individual solids for underbreak and overbreak is just using that model triangle utility merge option. Thanks, Steve.
Thanks, Steve. And next question, which was on my screen there now, will Vulcan 10 and the Workbench platform actually lower users' incurred costs? And is there evidence to show the Workbench platform itself improves user productivity in response to bug fixes? So it's in answering this one, I'll just go to the next slide, and you know, Maptek's a technology company, and I guess over the last 35 years we've developed a lot of technology in-house in terms of our Vulcan product, iSight, BassLogic, Perfect Dig, but we've also purchased technology such as Evolution and incorporated that back into our solution portfolio. So in doing that, each of these different softwares have had their own identity, they've had their own development teams, and in large they've worked in parallel. About 3 or 4 years ago, Maptek took the position that, hey, look, we need an overarching architecture, an overarching user interface to be able to integrate all these platforms, not just from a user point of view in terms of ease of use, but also from a maintenance point of view for ourselves behind the scenes, ease of development, ease of getting information backwards and forwards, ability to provide workflows between these different applications, and Peter just earlier showed the integration already of the Eureka into the Workbench. Vulcan being the oldest product in the portfolio was the one that needed the most tweaking, so we did that first. We broke the back of that. That's been released successfully in Vulcan 10, and now with Vulcan 10.1 you'll see, Workbench 2, you'll see the Eureka come and Vulcan 10.1, and then the introduction of the other products, the Studios and BassLogic, etc. So for us as a company, it lowers our overheads, therefore and everything's integrated, and you get much better use for you, the customer. As we develop further down this roadmap, we're also incorporating our partners. We have many partners, and we'll then open that integration path to them, so that when you're using not just Maptek products, but also some of our partner products, you'll be able to use that integrated workflow to get a much better and faster result. As well as the overall data and the workflow, the new Workbench allows us to start working on new licensing mechanisms and mechanisms for delivering software. So from Workbench 2, it's 10.1 for Vulcan, we're aiming at perhaps delivering a download and update service linked to a Maptek account. So for those that have taken on board the trial of Eureka with Vulcan 10, you would have had the first glance at the Maptek account system, which allows you to check out licenses or establish licenses. So in doing this and updating the ability to feed new software in faster, we can reduce the response times for bugs. So you won't have to wait for that 2-monthly cycle that Steve Hoffler mentioned in the first response to the question. Now, our ability to rapidly push fixes is going to assist customers where there are deficiencies in software. And this facility that we're releasing will also have a rollback or an opt-out mechanism for users. Some corporate customers aren't allowed to change their desktops, so those situations will be catered for as well. And in wrapping up, the new interface in the Workbench in Vulcan 10 has given a number of productivity improvements right now, and these are worth highlighting again. There's the search and filtering functions in the Data Explorer. There's integrated utilities like the text and the CSV editor. The multi-language capability, which is very important for our global customer base. The property editor for editing the attributes of various different data types, and the ability to right-click and get reports on different and individual menu items. So already we're delivering a lot of usability and benefits to you, the customers, and that will continue as the maturity of the platform and Workbench 2, 3, and 4 into the future. The next question, again, it looks like Steve Hoffler, you've been popular today. Question there about the pit splitter, which you've already demonstrated. So we'll just have a look at maybe the new drill and blast functionality that's coming out next year.
Yeah, so now I've switched over to Workbench 1.1, or which will be Workbench 2, Vulcan 10.1. And we've got 3 options currently that we can show in the drill and blast menu. Currently still updating other options, but we've got 3 that are ready to go at the moment. So under our drill and blast menu, we've now got a new create holes to freeface option. We've also got a merge blast option, and I guess we've always had an insert hole option, but we've modified this and made this a little bit easier or better for people to use. So at the moment on the screen, I will load up some blasts. So I'll just load up 2 different blasts. So we've got basically 22 and 23. One thing that haven't been able to do in the past is actually merge blasts together. So now we can merge blasts, and depending on which one we click on first, so you can see this bottom one's got naming coming down the page, where this top blast is actually opposite, it's got naming going up the page. So depending on which one we click on first, it's going to use that as its main sort of base to base everything off. So this has got naming going up, so when it creates a new one, I expect the naming to start sort of at the lower numbers down here and work its way up. Do you want a line by row or echelon? So essentially you blast side by side, or are they sort of on top of each other? Do you want to try and automatically match, or do you want to manually, you can actually draw your own sort of digitized lines to connect. I'll use the automatic one. So it actually draws them in for me and shows me this is how it's going to join them together. I'm happy with that. I can say yes. Now we get a new panel where we can give the new blast a name, give it a layer. At the moment it's on the same layer as one of these other blasts, so the original blast will be deleted. Whereas if I give it a new layer, I now get the option to actually not delete the original ones and keep them. And I can give the blast a name. We've got our normal naming options when we rename it. And I'll actually start going through and merging, starting with row 1, row 2, merging all the rows together into a new blast. And automatically renaming everything so it's following the one blast naming convention. Once that's finished, I should have a new layer created so I can remove the original 2 blasts. Now I'm left with 1 blast on the screen, and you can see the naming actually starts down towards the bottom and works its way up. Another option that we're bringing in is the free face option. So essentially if you've got a non-straight sort of free face side, and then we've got a nice fixed side, we can actually just get it to automatically try and merge all the holes together and equalize the spacing out. So we can use our free face option. You can select a spec file, which I've only got one in there. Give it a layer name. And essentially in your spec file, what it's going to ask for is, do you want me to use how many rows you've got in your spec file? So for example, I've got 3 rows in my spec file. So it'll keep the first row, the second row, and the third row as per the spec file. And then from the 4th row onwards is where it's going to do the free face forming. If I hit no, it'll do the free face right from the back to the front. So I'll hit yes, so I get 3 sort of straight rows and then start merging between a straight line and a crooked line. Give the blast a name. Select my polygon. It needs a reference line, which is our back. Then I need to select a free face line. So I can start it there, finish it up the top. And I want the highlighted section. Reference point where you're going to start calculating your burden and spacing from. Now you get a few more options. So when it creates these rows, do you want to have a nominal burden, or do you just want to create a fixed number of rows? So you can use your burdens to actually try and infill, or you can say, no, I just want 4 rows in there, 5 rows in there, and it'll actually calculate what the burden should be to fit that many rows. Also, your row style, so you can calculate all the rows irrespective of the burdens, or you can actually start trimming some rows off as some of these faces sort of come in and out. So I'll hit OK. It gives me a preview to say these are the lines that it's actually come up with. Are you happy with that? I can accept and then create. And what I should see is these first 3 rows basically straight, and then from the 4th row to here, varying between. So if I didn't want to vary it between so many, I could have inserted more rows into the spec file, so then it only did the free face, between a smaller amount of rows. And the final option we have working at the moment is we've made some changes to the insert holes option. So we can look at, say, hole 23. I can see that it's 19, 20, 21. So if I wanted to insert some more holes out this way, I can use the insert after. Again, there are 4 different options for inserting after. There's lots of tooltips in there to go through each one, but I guess a common type one will be I want to add in, say, an extra two holes after this one. I can put in a distance, so my spacing is 11 meters. So if I go out 22 meters, it's going to put a hole, and then I also want to insert one in between. And I can use the bearing from the actual row, and then it can automatically insert multiple holes. So there's 3 new options we've got up and running at the moment in 10.1, and these are still currently being worked on, so we hope to have a few more available by the time we actually get to release.
Thanks again, Stephen. And over to you, Peter, for a question about wireframing. Customers splitting, joining up wireframes between multiple sections, and some of the partial strings are a bit close and it's a bit messy. Is there a tool that can identify if the data or the strings are robust enough or not to form a solid? Is there a better way of doing this solid creation on narrow veins?
Thanks, Steve. Maybe not a tool so much, but certainly techniques and tips and tricks. Now, the first thing, I guess, to mention about any sort of modelling with CAD strings, especially making solids, is it's much easier to get your strings correct first and make the triangulation than make a triangulation from bad strings and try and fix the triangulation afterwards. So by that I mean things like duplicate points, point sequence, all that kind of thing are very important to get right. And also things like the tie lines here, we've got a few in this particular data set that sort of end in nowhere, so that's going to give you some issues in terms of making a final shape. So whether there's supposed to be a polygon at the end of those, I'm not quite sure. And also if we have a look at this data set, there's a few little time bombs in here. If you look at this string, if I actually shift, you're just temporarily using the move option, you see that there's actually 2 strings, one right on top of another. So I think this one is the same. If I was to model that just by selecting the entire layer, I would end up having almost doubled up points all over the place. So probably the best way to find that kind of thing is just to grab your data and label it. And if you label it with, say, something like a point sequence, you'll start seeing these doubled up, the numbers here are going to be doubled up with duplicate points and things like that. And also, your sequence is important. So if I'm trying to model along this particular stope, I want to make sure they're all clockwise or all anti-clockwise. So something like the consistent option would be a good option to use to make sure all your polygons have the same sense of point direction. That's just going to make life a bit easier for yourself. The other thing in general terms, this stope is very narrow, so if I'm trying to pick on the screen which line to use, I know this stope is sort of oriented north-south. So if I actually use my Y exaggeration a bit here, without doing anything apart from just changing how I view things on the screen, I can sort of stretch it out and make it easier for me to go, the red one, then the blue one, then the green one, then the pink one. In very general terms, in terms of the modelling of this kind of thing, you've got 3 chunks of stope here. You've got this thing down here, this one up here. I would do these 2 totally separately in single passes and save them off as separate triangulations. And then work my way backwards. So basically come in along one of the sort of legs, if you like. I would come in from here to here to here to the blue string and then do a partial that closed off around about this point here and save that bit of the triangulation. I would then do a similar thing coming along this other leg here and doing a partial up to this point. Then I would take these 3 or 4 full strings and make a separate solid and then join them all together, append them and close the resultant hole. And what happens after that, you get something along the lines of this sort of shape, which gives you the final stope shape, and it's closed and valid. So there are no sort of magical tool, I suppose, but intelligent use of the existing checking tools that we have, you can certainly make your life a lot easier. Just as a quick aside, if you're trying to not just model strings, but you might have some points from your scanner, so you've got pickups from within the CMS, you've got all sorts of control. This is Eureka. If I just select the same data pretty much and use the implicit modeling tool, which you can optionally have a crack at, I'm going to make a 1 meter triangle. This will happily model up to a couple of 100,000 points in a reasonable sort of time frame. In this case, it's only a few thousand. And literally within seconds, I've gone and made myself a pretty reasonable looking sort of pass at the stope. Now, this is going to be, you've got the classic sort of curvy sort of approach to a stope, and that's because the lines I fed it are actually curved. So if you wanted to include, if you wanted to be dead straight along the segments, you could control that as well. But basically, you've got a tool where you can throw data at it and let it do all the hard work rather than have to manually join things together. And that's available not as part of the free Eureka trial, the other part is, but it's certainly something that people can have a look at and consider. Just very quickly while I'm in this data set, I have another question came online about object filtering, so I'll just very quickly show that from Sean. So if I've got a string like this, the question was, is the object filter option in 9 available in 10? Well, yes, it is. So basically, it lives under the same name, but it has changed fairly substantially, and it does look a bit scarier than it used to. The option that we used to have, that most people used, where you just sort of selected an offset distance, that's now called by distance recursive, which is a fancy way of saying this is my perpendicular distance to the line. Now, the way this entire tool works now is pretty cool in that if you select your object, especially if you hit it, it's going to give you a preview of what it's trying to do. So you can see that the white line is my original line, the yellow line is my new suggested line, and if I actually change this, you can see how the filtering is changing dynamically by how I adjust the actual parameter. So it's sort of much more dynamic than it used to be. The other option we've added, which is also really nice, is interactive, where you can just drag a slider along, and if you look at, as I'm sliding the more to fewer points, I get pretty extreme filtering. If I go more points, and so you can just sort of eyeball it until you're happy with what it looks like, and then hit the save button to update the filtering. So yes, the option is there. It's got a different name, and there's some really nice new options to play with as well. Thanks, Stu.
And Eduardo, to wrap up with the last customer question, there's a customer who's using an older version of Vulcan, is not quite sure if the feature is available in Vulcan 10, but they're looking to lock a point on a polyline so it cannot be edited without unlocking it. Have we got a solution in there?
The short answer is we don't have a proper option to lock a point in an object, but probably we've got a couple of different things that we can actually use in order to achieve what we want to do. So I got a line here. Let's put some point sequence. So I got a different point here. Let's say that I don't want to move the point 4. We got option and point insert, which is replace a string. So you can actually grab from point 1 to point 4, which the 4 is going to be locked in any case. And then you can move around and then interpolate or doesn't interpolate. And then you will have the same position of the point. That's one of the things that we got there. The another thing is actually in another way around, but I'm gonna take the opportunity to show this one as well. Probably it's a very old option, but maybe it's usable for some new user as well. So you know how the line here is in this particular plane that we are playing at the moment, 2210, which is basically the plane that we got here. But if for some reason I change the plane here to, let's say, just let me move this one a little bit. There we go. So if we change this one to 2004-500, let's change here then. Okay, and then I try to move the point. I can actually click in the point and going to point it move. And when you actually move in this point, essentially it's going to take the coordinate that you put in here. Now, if you really want to move the point and keep that one, just press the shift. And then when you are moving, you're going to keep the previous or the existing coordinate as well. So Again, there is not a specific option to lock a particular point, but there is a couple of things that we can play around. We're going to pass this one to our development team and see if we can actually do something in relation with this question.
Thanks, Eduardo, for wrapping up that last question, and thank you all to the customers who sent through questions both in advance of this webinar, but also live today. If you need any further assistance, obviously contact your local Maptek office for further information about any things to do with Vulcan software. Now, this panel forum today has made several mentions to the latest Vulcan versions. For those that haven't got that, you can go to the users.maptek.com page, as shown on the slide at the moment. When you do go to that page, you'll see a listing like that with the various different software that is available for download and the release, the maintenance dates that are required to be able to access that software. During the webinar, we've also mentioned the other ones that we've run earlier this year about Vulcan 10 and related items. The ones that are listed there on your screen have been run here by our Australian team, and they are also available for viewing on that web page there at videoswebinar.html. And note that this webinar that you're listening to today will be processed, and probably by mid to the end of next week will be up on our web page under webinars as well. For if you want to review that, or if you had some colleagues who couldn't attend, that will be there for everyone to share. Now, if you're in a position where your corporate IT don't allow you to streamline video, just send us an email and indicate whether you can cope with a DVD or a USB key, because we've done that to quite a few customers, so they can take this information on the road with them, or they can look at it from the DVD or USB and still get benefit. We're finding that had some very good feedback from the webinars. People, as I said earlier, like the content, so we want to continue this into next year, and in doing so we'd like to hear from you as to what you want to, what parts or what aspects of Vulcan do you need some assistance, or does your team need assistance? Let us know, and we'll put a person onto it and we'll get a webinar out to you. Contact details for Maptek for Australia here is both their support email and phone numbers. I'd like to thank Stephen Hoffler from Brisbane, Peter Owens from Sydney, Edward Calomo from our Perth office, and myself, Steve Sullivan, in Adelaide. Thank you for listening to us today. Thank you, everyone, for your content, and look forward to speaking with you again next year. Bye for now.